Okay, so your equation of x is equal to cos t, and the value of x, the first value is equal to 1. So you know that to get what is the, you need to think, what is the value of t that you obtain your value of x is equal to 1. So meaning that you know that cos 0 is equal to 1, right? So meaning that your t is equal to 0. Okay, and then we go with the second one. So x cos t, x cos t is equal to 0. So cos what value of t so that the equation of cos will equal to 0. So you know that cos pi over 2 is equal to 0. So meaning that your t is equal to pi over 2. So that's why we have, okay, that's why we have the interval for t is from 0 to pi over 2. Okay, then that one is for x. Now we want to find equation for yt. Okay, so the value of y is from 0 to 1. Okay, so if x is equal to cos t, since this is a circle, so meaning that your y is equal to sin t. Y is equal to sin t. So differentiate equation of y, so you get dy over dt is equal to cos t. Alright, so dy is equal to cos t dt. Okay, so same goes here like this one. Okay, like this one. So we do it here. Okay, so we know that your t, the interval for t is from 0 to pi over 2. Okay, from 0 to pi over 2. So here, up here, you already got your equation for x and also y. And then after you obtain your x, you can find your dx, right? So to find dx, so dx is equal to this one. Then after you obtain your equation of y, so you can find your dy. Okay, so you substitute inside this one. So you substitute what is your x, what is your y, what is your dx, what is your dy here. So you get this one. Okay, so integrate this one from 0 to pi over 2. So you need to integrate this equation, negative sin t plus with cos squared t dt. So to integrate this one, then you can directly integrate. But to integrate this one, cos squared t, so you need to use trigonometry identities. Okay, so this is the formula that you can use in the identities. Cos squared t is equal to 1 over 2 cos 2t plus with 1 over 2. So this one we substitute it here. Okay, then we simplify, then we got the answer like this. Or you want to give me in 4 decimal places also can. Alright, so this is how we answer this question. This question is a little bit different with the example previous. Okay, so this is how we answer this example. So usually if it is a circle involving with circle, so usually the equation for xt is equal to cos t, and then the equation for yt is equal to sin t. Okay, alright. So this is now we want to enter line integrals over pieces smooth curve. So meaning that it is the combination. Let's say for this example, so this is your C1. So this is your first line integral. So we denote it as C1. And then this is your second line integral. So we denote it as C2. So to get the line integrals, so meaning that it is the combination of line integral for C1 plus with the line integration for C2. Okay, so we go with example 11 here. So this is like example just now. Okay, like example just now. So now here, alright, they ask you to evaluate the line integral for this one. So this is a quarter circle. and the point is moving from 1, 0 to 0, 1. And the straight line segment, so this is the first one, moving from 1, 0 to 0, 1. So meaning that this is your first line segment, which is side C1. And then you have straight line segment from 0, 1 to 0, 0. So this is your C2. So meaning that you need to find C1, then plus with C2. Okay, to evaluate your line integral, so you need to find this one and then plus with this one. So basically, on how to solve this one is just the combination of what you have learned just now. Alright, now we want to solve for C1. Okay, we want to solve for C1 here. So C1 here, you know that the point is moving from 1, 0 to 0, 1. Okay, so the T here, on how to obtain T here is like previous example. Okay, you just need to refer to previous example. So we already done in previous example, so your T is from 0 to pi over 2. And then how you obtain the equation for xt and also yt, this one is like in previous example, so you just refer. Okay, so now after you obtain your xt and also yt, so you can find what is your dx and what is your dy. Okay, so find your dx and also your dy. Then what you need to do is you need to substitute what is the equation for y, what is the equation for dx, what is the equation for x, and what is the equation for dy here. So you get like this. Okay, so you solve, then you get this one as the answer. Okay, so this is for C1, not yet solved. We just get the line integral for C1. Now what you need to do is you need to get line integral for C2. Okay, so now we want to do for C2. So if you refer to the sketching just now, C2 here, you know that this one is the straight line segment. So you're moving from 0, 1 to 0, 0. So the line is, the point is 0, 1 to 0, 0. Okay, so now we want to find C2. So this is straight line segment. So we need to find what is your xt and also yt. So to find xt and also yt is for this one, for C1. So this one is because this one is a circle, right? So we know that xt is equal to cos t and yt is equal to sin t. So for straight line segment, you need to use this formula like in the beginning. So xt, you know that to find your xt is equal to x1 plus with x2 minus with x1, then multiply with t. So you have the points here, so you just substitute inside this one, so you get this one. And then for yt, you need to use this formula. Yt is equal to y1 plus with y2 minus with y1 t. Okay, so substitute using these points, so you get this one. So you get your equation for yt is equal to 1 minus with t. Okay, so after you obtain the equation of x and also y, so you can find your dx and also dy. Alright, you can find your dx and also dy. Okay, so how to obtain the interval of 0, 1 here? So same thing, alright, same step to find the interval for t. Okay, so you know that, let's see for x, we go for y. So your y, you know that the point is moving from 1 to 0. So the equation of y is 1 minus t. So let's say we take for the first point, which is 1. So you know that your t is equal to 0. And then we go with the second point, which is your x, which is your y2. So 1 minus t is equal to second point, your y2 is 0. So meaning that your t is equal to 1. So that's how we obtain the interval of t, which is from 0 to 1. So after you obtain your xt, you know your yt, you know your dx, you know your dy, then you substitute everything inside this function. Okay, so when you substitute inside this equation of line integral, so you get the line integral for C2 is equal to 0. Okay, so not done yet. So you need to find the line integral for overall, so meaning that it is equal to line integral for C1 plus with line integral for C2. Okay, so you just need to add it up, so you get the answer as this one. Alright, so that's how we get this one. Okay, alright. So meaning that this one solve for line integrals for scalar. Alright, line